Today, a problem for transverse shear stress. Question is: a simply supported beam carrying a simply supported beam carrying UDL means uniformly distributed load. One end is hinge joint and another end is roller joint. And the span of or length of the beam is 2 meters, and the load is 10 kilonewton per meter per unit run load intensity. This is, and the cross section is, and this beam cross section is T section. Means cross section, side view of the cross section means side view of the beam. Side view of the beam. Side view of the beam, T section. The dimension, this is 120 millimeters, this is 20 millimeters. Total length is 140 millimeters, and this is 20 millimeters. Now calculate shear stress for this T section. Calculate. Question is shear force distribution for this beam. Calculate. Question is calculate shear stress distribution of beam. First of all, calculate bending moment and shear force diagram. Just need shear force diagram. This is, suppose this is A, this is B. First draw free body diagram of the beam. First step is this is RA, this is RB, RAY hinge joint. There is two joints, one is vertical and other is horizontal. and this is the small w per unit run. Now first step of free gas. Second step is equilibrium conditions. Summation of fy fx equal to 0. So Rax equal to 0 and summation of fy equal to 0. Ra equal to root over Ra x square Ray whole square. So Ra here is 0. So Ra equal to Ray. So Ra. So Ra plus Rb. Suppose put the value. So 10 kilonewton per meter. And this is 2 meter. Upward force Ra and Rb and downward force is 10 into 2. The length 20. This is equation number 1. And now the summation of Ma, the moments about a-axis. Suppose counterclockwise Rb into 2 plus this is 10 downward clockwise sense, so positive. Total weight of the UDL 10 plus into 2 total into the distance is, it's always at centroid of the centroid of the centroid past centroid, and this is 2 meter, so centroid is 1 meter, so into 1 equal to 0. So Rb equal to 10 and put the value equation 1. Ra equal to 10 kilonewton. So 10 kilonewton, this is also 10 kilonewton. Understand? Now draw now shear force diagram. Shear force at point load at point load there will calculate shear force twice. Shear force at just before A is 0. Shear force at A. We know the sign convention for shear stress. This is left right, this is positive, and this is counterclockwise, this is negative, left right, negative, no, left side upward, this is positive, plus 10, and shear force just now calculate from right side. Shear force just before B is 0. Shear force at B, right side upward, this is negative, so minus 10. The load, point load is minus 10. Now draw the shear force diagram. This is V, this is x. Now left side, first of 0, this is a, this is b, here 0, and now this is 10, and here is also 0, and this is minus 10, this is my 10. And when UDL acts between 2 points, the shear force diagram is inclined straight line. So this is inclined straight line. This is positive, this is negative shear force diagram. So we can easily, we know shear force, shear stress equal to shear force into A into moment of inertia a plane above the plane at a distance y from neutral axis. This is moment of area. This one is A into y bar is the moment of area above the plane at a distance y from neutral axis, and I is the moment of inertia about neutral axis into B. This is the width of the cross section. Here, suppose here this is point. Suppose here shear force is here 0. Shear force is 0. So at this point, this is the midpoint. At these points, bending moments either maximum or minimum. And here, and this is draw different points. This is A, B, C, D, E, F, G, H, I. At point D, E and F, point D, point E and point F, shear force is 0 because there is shear stress is 0, because at this point shear force is 0. But point A, B, C and point A, B, C and point G, H, I, there is a shear force is maximum, but their direction is different. Now calculates shear force at top fiber and neutral axis and the bottom fiber. Calculating the shear force, we have to first the position of the, we have to calculate position of the neutral axis. For neutral axis, this is y. From the x-axis, position of neutral axis, y bar equal to, we know this is 1, suppose this is 2. A1 into y1, A2 into y2 plus A1 plus y2. A1 into, here A1 equal to 120 into 20, 120 into 20, and A2 equal to, this is 120, 140 minus 20, 120, 120 into 20, and calculate, and y is the calculate from the top fiber. Reference is, this is the reference, this is the reference, top fiber is a reference. So 120 2400 into y1, this is the from the reference plane, this is 10 plus 24 y, this is 20 plus y2 equal to 20 plus 120 plus 2, this is 80, and y1 equal to 10, 80, 24, 4. So calculate y bar equal to 45 millimeter. The neutral axis is neutral axis, this is neutral axis, 45 from the top fiber. Understand my point? Now calculate the shear force. First, a top fiber. At top fiber, shear stress is 0. We know from previous lecture, but shear stress just before join, just before join. Now shear force calculate just before join. A into y bar, A into 120 into 20 into y bar. Y bar is the neutral axis is, and this one is 10. So y bar equal to 35, just before joint, this portion. So calculate it. This is millimeter, this is 1 millimeter cube, and I neutral axis I1 plus I2. I1 plus I2, 1 plus 12 for this about neutral axis, 120 into 20 cube. Okay, and the area is 120 into 20 into the neutral axis is 45, and the center 45 minus 10, and y2 value is 1 plus 12 into 20 into 120 cube plus 120 into 20, and this is square, and the this one is 60 80 80 minus 45 whole square. So I in a moment of inertia about neutral axis is 8840 millimeter to the power 4. Now calculate just before joint. Shear stress equal to shear force is shear force is this section is this just before joint. Shear force is 10 into 10 to the power minus 3 Newton, and this is 84,000 divided by 8840,000 into B. The B is 120, so the value is 0.97. This is 1, this is top fiber, which is just before joint, Newton per millimeter square. Okay, now at shear stress at joint or below joint. This is joint. Now shear stress equal to shear 10 to the power minus 3 area at these points is below. Area is this point, 20 into area is 20 into 120 into y bar. Y bar is at these points, and y bar is 35. This is 10 and this is 35, 45. They are 35, and I equal to already calculate 8840,000 into B at this point, with is 20. So value is 4.75 Newton per millimeter square. Now D, shears at neutral axis. Shear stress at neutral axis is 10 to the power 3 into the area about